And here come our attendees. Welcome, everybody. Please find a seat in our virtual room. We'll give folks just a few more moments to file into our virtual meeting room. All right, well, good afternoon if you're in the Eastern time zone, and welcome back to this afternoon's 3 o'clock session of FHIR North. I'm glad to see so many folks attending. Thank you for having stamina and sticking with us all afternoon. I hope that you've been learning and enjoying the content that we've been able to collect and deliver to you today. Personally, I've spent a lot more time in the tech track than I ordinarily do, and I've been learning a lot. And so thank you for letting me walk among you. Today, it's my distinct pleasure to introduce our friend, Josh Kelly. Josh is a co-founder of FHIR, and he is working on refactoring healthcare through patient access APIs. Josh is an open source contributor and one of many co-authors of the Karen Digital Insurance FHIR IG. Like many of the speakers today, Josh is Toronto-based and is now in his third startup. In this talk, you're going to learn about synchronizing or transferring data between FHIR servers. As an implementer, you might encounter the problem of needing to move resources from a FHIR server that you don't control into one that you do. Copying the data isn't necessarily straightforward, especially if you're working with patient access APIs. Please remember, as we go through this presentation, to put your questions into the Q&A at the bottom of the video Zoom window. And at the end of Josh's talk, I'll pick the questions I find most interesting and present them to Josh for his insightful answers. And with that, thank you, and a big round of applause for our friend Josh. Over to you, Josh.
Well, thank you for that warm introduction. Welcome to my session, which is titled Resource Synchronization Across FHIR Servers. Really, though, I need to admit something, that actually this talk is about copying between FHIR servers. Synchronization implies that we're going to keep the data in sync. So once we do it once, we need to keep it in sync. And that's actually a slightly different problem than the one that I've had to solve. So we're going to exclude synchronization, and we're going to focus really on copying. As mentioned, I'm the CTO at FHIR. I'll have a link to that project at the end of the talk as well. Happy to answer questions, but please, I'm going to hold them to the end, so make use of the Q&A function. So the problem that we are trying to solve, the problem that this talk addresses, came out of the work that I've been doing at FHIR. Very briefly, FHIR builds a patient access API on top of 200 FHIR endpoints. I think when I made this slide, I actually made an error. The number is actually over 300. So we have a pretty unique problem, but hopefully some of you recognize some of the challenges of that. The core of our workflow is that when a patient authorizes our access to their data through a patient access API, we need to copy the FHIR resources from the originating server to our own. So that is the problem in brief. This is a FHIR server that we don't control, and we want to copy the data to a FHIR server that we do control. So as I revealed, I'm not going to be discussing how we can keep resources in sync. Happy to answer questions about different resources that we might point to be able to do that, though. This talk also isn't about copying all the resources. That's actually a simpler problem. talk is also not about provenance. So I'm not going to touch on how we might store a record of origin of data. And that's an important challenge that shouldn't go unnoted, but is outside of the scope of this talk. The place that we're going to spend most of our talk time today is on two parts of this problem. The first part is finding resources or extracting the resources. And the second is saving them. So we need to find the resources in an originating server and then store them in our own destination FHIR server. And the scope that we want to consider this problem in terms of is for a patient. So we can think of a FHIR server as storing data for many subjects, for practitioners, for patients. Really what we want to do is achieve the task copying all of the data that belongs to a particular person, particular patient, that is granted us access to that data. So our first strategy is the easy one. Thankfully, FHIR has a patient everything operation. Pretty simple and straightforward. We can make one GET request to the base FHIR URL /patient, their ID, and then we use the $ to connote an operation, and we use the operation called everything. This is easy. We got a big easy button here for a reason. It's one request, usually. We might have to paginate the results, but usually it's just one request. Obviously, though, the challenge with this is that our originating server has to support the operation. So when this is possible, simple, no problem. It's not always supported, though. So if it's not, we can move to a different extraction strategy that's similar in that it can be efficient, requiring maybe just one request. And I actually didn't know this when I started this project, but the batch transaction functionality in the base FHIR REST API actually supports not just hosting of data, so create operations, it actually supports read and search operations as well. And so what we're able to do is send in one request, in one post operation, we can send a bundle that includes inside of it several read or search operations. This is actually pretty useful because, again, one request, really nice. We can get back all the data that we need. It's uncommonly supported in the wild, at least as far as patient access APIs go, but it is possible. Pretty straightforward. We submit a bundle like every batch transaction. So starting step one up here. Step two is we need to indicate that the type of this bundle is a batch. And then in our entry array, we list the read and search operations that we would like to perform. So this is a simplified example here where in steps 3 and 4, we are making two requests. So we are asking the FHIR server to process patient read request. And then 2, we're asking it to make a explanation of benefit request. And we're using the patient search parameter here. So if neither of those options are supported, we have to get our hands a little bit dirty. The simplest way that we've accomplished this is through individual search operations. So how does this work? Well, first of all, we can use the capability statement to issue search operations that are supported for the resources that are supported by the server. So we take a look at the capability statement and we determine that this particular server supports encounter, observation, patient, etc. And then we issue search requests for those search operations for those resources. Ideally, when it's supported, we also pass a search parameter such as patient, target, or subject to scope that search request. When we're done, we should have a series of bundle resources that comprise the data that we've extracted. There are some problems with this approach that have to be solved through a fourth extraction strategy. So the problem with this approach is that for several resources, let's take organization or practitioner, it isn't reasonable to make a search operation and extract all of those resources. What we're trying to do is get the data that belongs to a particular data subject. So in this case, a patient, that's our goal. But the organization resource or the practitioner resource, we should expect it's not uncommon for a FHIR server to support a search operation for those, but we don't need all of the practitioners or all of the organization resources that are on that FHIR server. We only are interested in the resources that are referenced by the patient compartment data that we've acquired. So extraction strategy 4 gets pretty complicated, but is actually quite elegant. We form a graph of resources and we traverse the graph. And every time that we find a reference, for example, in an encounter to an observation, when that is a relative reference, we resolve the reference. So if we see that an encounter references observation A, we make an additional request, a read operation request, and resolve that data uniquely. The downside of this approach, of course, is that we will quickly balloon the number of requests that we have to make. So this is really unbounded. The limit is the limit of references. We can do some smart things. So we can make sure that we are only resolving a reference once, but ultimately the number of potential references is unlimited. Credit for this idea goes to Michael Graf, who is the author of a Python FHIR client known as FHIR Kindling. I've borrowed his imagery of this idea. You can see that library for an example implementation of this approach. Note that we can combine these approaches. So we can take the idea of graph traversal, we can take the idea of individual search operations, and we can combine those with the batch strategy to potentially reduce this to a single request. But that's really in the ideal case. So through some manner of extraction strategy, we should end up with the resources that we've successfully extracted. Okay, that's only one half of the problem. The second half of the problem is putting the data somewhere. So we want to save it in our own FHIR server. And of course, we encounter a number of problems with that. The first problem is quite basic. In FHIR, an ID field, so a resource ID, is defined as a string. It could be of, I believe, any length, but certainly it could be long or it could be short. And there's no guarantee that that is a universally unique identifier. So when we extract resources from another server, simply saving them won't work, because when we attempt to insert an ID that we haven't generated, there's no guarantee that that won't create a collision in our own data. So corresponding to several extraction strategies, we have as well several load strategies. The first load strategy is that we have to address that first problem. So we need to replace all of the IDs, and not just the IDs, but also the references. We need to replace those with universally unique identifiers that we've generated. Well, how do we do that? Fortunately, we can traverse our graph of resources again. So on the left, we see an example of an observation resource, very minimalistic observation resource, that has two of these kinds of IDs. So an ID here and a a relative reference as well. We also see a second resource of patient. So the ID on the observation, indicated by this red arrow, is 16038, etc. The relative reference underneath the subject field of that observation is a reference to a patient of 3310, etc. And we see that our second resource is a patient that has that same ID. Okay, so we need to iterate through each of these resources, and as we go, replace each of these IDs and relative references. So on the right, we can see how that might play out. So we've replaced the observation ID, and we've used a universally unique identifier. And then we've replaced the ID for the patient as well. And you can see how we've used the replaced ID on the patient, but also changed the relative reference on the observation. It's important as we do this, though, that we have to keep a map or a dictionary of the old identifier to the new identifier. Because once we've replaced the resource ID, any references to that resource ID in the rest of our bundle need to also be updated. This also is somewhat simplified. You might be asking, well, what about more complicated cases? What about contained references, for example? And unfortunately, that is beyond the scope of this talk, but is similarly solvable. The second load strategy that's important is to disable resource validation. Having connected to hundreds of different FHIR servers, I think you can imagine that there are different levels of quality in the data. FHIR is a very permissive specification. And if we enable resource validation, we really rely upon good luck to actually get that job done. And there's a reference here that I appreciate called Postel's law for John Postel, which is that he's an early internet pioneer, which is that we should be conservative in what we do, but be liberal in what we accept from others. So we should basically be willing to accept any resource of any shape, as long as it follows the baseline requirement defined in the base resources. So the schema of the base resources, we should allow those, but we're probably going to end up having to be pretty liberal about every other form of validation. This will be especially true when it comes to profiles. In our experience, we can't necessarily trust the validity of a profile. So loading strategy 2, disable resource validation. Loading strategy 3. So once we've completed our mission of changing all of the identifiers and references, we can create a bundle and use a batch transaction again. Something that is extremely helpful in this approach is a feature in FHIR's API, in its REST API, called update as create. So normally when we use a create operation in FHIR, we don't specify an ID. But in this case, we do have IDs, but we don't expect those resources to exist. So we need to use a feature called update as create, where we're doing put operations or update operations and put requests for each of the resources that we're creating. And you can think of this as just like an upsert. The FHIR spec, I believe, even uses that term. So here we see that playing out in creating this bundle, this transaction bundle. Each entry has a request field where we specify the operation that we're asking the FHIR server to process. So you can see method put corresponds to an update. This resource is not expected to exist. So when the FHIR server processes it, it will find that, oh, this ID is not being stored. We actually need to create it. That's the simple path. There's lots of other problems that if you were attempting to do this yourself, you will find along the way. But those are the strategies that I wish someone had told me when I started this project. I'm happy to answer questions. And if you'd like to take the conversation beyond FHIR North. I'm available on Twitter, and that's my email address. Happy to answer some questions.
Perfect. Thanks, Josh. That was very helpful. And as I said to one of our other presenters earlier today, it was clearly enough described that even a non-technical individual like myself could understand most of what you were saying. So that's quite a feat, and I appreciate the effort and preparation that went into that. We do have one question from our audience. I have a couple of questions that I've come up with on my own as well, but we'll start with the audience question. Audience member asks, Josh, if you're fetching patient data from multiple sources, how do you dedupe the unique user IDs that you've created, or do you know to subsequently reuse the same UUID for the patient? So I guess that's sort of an MDM question, is what we would call it in our team. Yeah, how do you handle that?
Learned a few tricks along the way. The first trick is that a UUID can be generated in a few different manners. So there are, I believe, there's at least 5 versions of the UUID spec. And one thing that's really important about generating them today is that you can generate a completely random one. So using UUID v4, we can generate completely random IDs. And that's helpful, but with UUID v5, we can actually namespace them. So what is that? Well, it means that given during the process of creating the UUID, we can actually specify an input, and that input will essentially behave like a hash, meaning the same inputs will produce the same output. That's really, really, really useful. So for us, what we do is we provide the input. Half of the input is the original ID from the originating FHIR server, and the other half of the input is a unique ID that we assign to that FHIR server itself. So that's really, really useful because it means that we can consistently generate UUIDs that are deterministic, but scoped just to the particular domain of a particular FHIR server. We do one extra little trick, though, that's important in our case, and to fully answer the question, it's really important for us that we enforce logical isolation of this data. So patient access API, this data that we're copying, really we're copying the data that is unique to a particular person in a particular system. So for us, we do not want to share resources or references to resources, even when they could be deduplicated. So for example, if 2 patients, patient A and patient B, both have a history with a particular practitioner, even though that practitioner is logically and in reality the same person, we store 2 separate copies with separate identifiers. And we do that deliberately. And that actually is the third piece of the input. It's the patient ID. So we do that so that we can guarantee complete compartmentalization, even beyond resources that are not fully patient compartmentalized, like a practitioner or a physician. It's a great question, and for us, that was an important design challenge.
All right, thanks for your answer, Josh. I'm sorry I can't credit the question asker since they're showing up as unknown to me. Another anonymous question asker asks, how are patient merges reconciled with FHIR? I think that's probably related to the previous point, but I may be wrong.
It's a little bit related. We do not attempt to, so first of all, we don't attempt any synchronization. So we're not continuously synchronizing new data. So for us, a little bit, we're avoiding that problem, I would say. Our particular use case doesn't require us to continuously handle new data. I think there's a related question maybe about managing data across multiple systems that I see that I could maybe answer here as well. That question says, do you join the single patient's data across multiple source systems? Are you creating a single longitudinal record for this patient? Not directly in the FHIR server itself, So separately, we have the notion of a patient in our system, and that patient can have multiple patient resource entry points. You can think of it that way. So we do not attempt in the FHIR server itself to unify those resources in a single patient resource. And
Right.
we probably could, but for us, we rest easier knowing that we've successfully achieved logical isolation.
Right.
Hopefully that makes sense.
Okay, I think so. And
I'll take your word for it.
one of the things I thought was interesting, and it may be completely obvious to the more technically astute among our audience, but you mentioned that you have, 4 different approaches to collecting the data earlier on. I was wondering, and maybe it's this is again a really thick question, but can you programatize this? Like, can your software hit a capability statement, parse the results, and then programmatically decide on one of those 4 approaches? Or are these more, theoretical approaches for how you would build a tool that does A, B, or C?
So a funny thing that you realize when you connect so many different FHIR endpoints is that capability statements lie. So unfortunately, the capability statement is not fully trustworthy. Servers do not conform to the behaviors that they say they do. Now, that's okay if they have an undisclosed behavior, but it's bad when they don't conform to the thing that they positively say they do. So what we do is through actual usage, we determine if the everything operation is supported, if the batch operation is supported, and we attempt all 4 strategies in some manner, going down to the lowest, the most, we do the most work if we have to do it, in other words. So programmatically, we're iterating through these approaches, and that's what I would recommend if someone was going to try to achieve something similar.
Okay. Thanks, Josh. And there's one question that I don't think we've addressed yet. Again, from unknown questioner. Unknown questioner asks, do you prefer to sync per transaction, or do you create batches? I seem to recall you using batches, but again, maybe I'm just curious to know if that's the answer to your question.
I think there's a subtlety to this question, which is that we do we attempt to do just one transaction, so one batch transaction, one bundle. However, the file sizes can get actually very, very, very large, and so this is actually an unsolved problem for us. We have a ticket in the next work stream split the bundles. So we're going to look at the file size limit, but that's going to be dictated by your FHIR server and the load balancer in front of it.
Okay, great, thank you. And okay, I think that we are at about time, and I believe that we have. Actually, you know what? There's a question here maybe we haven't addressed. How do you manage potential error handling from each single request in the bundle? Presumably that would be a validation error of some kind that the questioner is asking about.
Yes, so this can happen in 2 places. This can happen in response. So in response to our attempt to extract. So generally, a good FHIR server will return a bundle back to you. So it will return a bundle, and if one of them fails, it should return an operation outcome. And so you can handle that uniquely. And then obviously the other half of that is the batch transaction unsaved. So in both cases, though, disabling resource validation is one mechanism that we have to save no matter what. So if we encounter an error, we can still save. We'll just have an unresolved reference, but that may or may not be acceptable depending on your use case.
Great. Well, thank you very much. I think we are now officially at time. So thank you, Josh, for your thoughtful and well-prepared presentation, and all the best in your endeavors at FlexPath. And yeah, we'll look forward to learning some more together in the rest of the sessions today. Thanks again.
Take care, everyone.